A specific type of function which has applications in multivariable calculus is called the Cobb-Douglas production function. It's a function of the form f of xy equals some constant k times x to the m, y to the n. So some number times x raised to some power times y raised to some power. It's used by economists to describe the number of units, which is given by f of xy. So the number of units produced from the utilization of x units of labor and y units of capital. So since derivatives tell us about rate of change, one thing these sorts of questions can be used to answer is, would we be increasing production if we invest more in labor or in capital? So in example 4, we have the productivity of a certain country with the utilization of x units of labor, y units of capital, given by this function. We want to find f sub x and f sub y, so the derivative with respect to both x and y. So we'll ask Wolfram Alpha to find the derivative of that function with both respect to x and y at the same time. It will output two results for us, the first one being 64y to the 0.36 over x to the 0.36, or what we could also do is rewrite that as x to the negative 0.36 and bring it up into the numerator, which will give us f sub x equals 64 x to the negative 0.36 y to the 0.36, and our derivative with respect to y would be 36 x to the 0.64 y to the negative 0.64. So if the country is now using 400 units of labor and 500 units of capital, we want to find the marginal productivity of labor and the marginal productivity of capital. So labor is our x value in this function. So what this means is to find the marginal productivity of labor, we would want to find f sub x evaluated at x equals 400, y equals 500. And to get the marginal productivity of capital, capital being our y value, we'd want to evaluate that partial derivative with respect to y at x equals 400, y equals 500. So we can evaluate first the partial derivative with respect to y. For x equals 400 and y equals 500. And Wolfram Alpha seems to be dragging on me a bit, so hang on just a second here. So, sorry about that, but once this finished calculating, we did get a result of 69.35. So the marginal productivity of labor is approximately 69.35, and then similarly, we could evaluate the partial derivative with respect to y at those same values to get approximately 31.21. So keeping in mind that these represent the change in our function value, so the change in productivity, for the greatest increase in productivity, we would want to encourage the increased use of labor. Because increasing the use of labor by 1 unit is going to yield a larger change than increasing the use of capital by 1 unit. So it comes down to comparing those two numbers and see where we get that better rate of change. In another example, we have a bowling ball manufacturer with a Cobb-Douglas productivity model. X is labor, Y is capital, both in thousands, and Q is the number of bowling balls produced in thousands. So again, we want to get the partial derivative with respect to both X and Y. Which gives us our two results, which we'll go ahead and round to 0.56 and 0.19 for those constant multiples in front. So we're going to get Q sub x equals 0.56, x to the negative 0.25, y to the 0.25, and Q sub y, partial derivative with respect to y, will be 0.19, x to the 0.75, y to the negative 0.75. So similar to what we did in the last example, to get the marginal productivity of labor, we'll evaluate the first derivative with respect to x, evaluated at 13,600 and 1,200,000. Keeping in mind, though, that x should be in thousands and y should be in thousands. So what this actually means is our x value should be 13.6 and our y value should be 1200. So this is our x coordinate, 13.6, but in thousands that represents 13,600. Same with the y coordinate. So we want to evaluate these two functions at 13.6, comma 1200. Which would give us results in this case of 2 and 0.01. So we could go back to Wolfram Alpha to evaluate those. And again, we're interested in would production increase more rapidly with 2,700 more employees or $200,000 additional capital. So in this case, we're seeing that greater rate of change from our marginal productivity of labor. So the better choice here would be to increase our number of employees. So to increase our number of employees by 2,700.